So when we're talking about a Bunsen burner, please do not write this exactly as I write it on your lab. This is just to help you in case you forget some things. It is methane gas and it's a combustion reaction. So just knowing that it's a combustion reaction, you should know whether it's endo or exothermic. Remember, for exothermic reactions, the surroundings are heating up. And for an endothermic reaction, the surroundings are cooling off. Some of you tend to get that backwards. So an exothermic reaction, the surroundings will heat up. In an endothermic reaction, the surroundings will cool. Make sure for each of these, you label clearly, my system is, my surroundings are. You tell what the, if it's endothermic or exothermic, and then what undergoes temperature change. The surroundings are always going to undergo the temperature change. Just make sure you explain for each of them whether they're increasing or decreasing. Same thing for this. If you don't know whether this is an endothermic or exothermic reaction, Google this reaction and you will be able to see. This right here, number 2, it's a little bit tricky because there's one word in here that may get you. Right here, we're composing HGO, but they want you to figure this out when it's decomposing. So that means you're flipping this reaction. And remember, when you flip the reaction, the delta H changes. Remember, you just set this up. So you have grams to moles. And then you just use these, your kilojoules with how many moles. You have 2 moles, you look at the coefficients. This is all review. And that's your kilojoules. Okay? Make sure you flip that reaction. This next part, if you look on the back of your lab, you will see a table B, and this is where we get these values at. Make sure you write this part. Make sure you write legible. Write this step. Don't just put a whole bunch of chicken scratch down. Make sure you are writing everything. This is for your pit grade. This is for your pit lab. Put in your values and then end it with your final delta H value in kilojoules. And then again, make sure whether it's endo or exo. This guy right here, you have to write a net ionic equation because they don't give you this. Remember that LiOH breaks apart into Li aqueous plus 1 and OH negative. And make sure that you remember the coefficient goes to the Li and the OH, and the phases of the Li and the OH are both aqueous. So again, you'll write out your whole delta H, put all your products, put all your reactants, and then you'll write it again with your values, and then you'll show your answer in kilojoules, and then you'll have to say endo or exo. Make sure you show all your work. Some of you just buzz through this and you lose easy points. All right, so your lab instructor is Tamika. This is a very slow moving video, but you'll be fine. These you get right from the video. I would start off by making sure you put grams for all of these. Make sure you put degrees Celsius, degrees Celsius, degrees Celsius, da, 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 da. She tells you all of this. She tells you all of these, okay? These are gonna be about 100 degrees Celsius to make sure that's all yours. These are all gonna be about 20-something degrees Celsius, and these are all gonna be in the mid-20s, okay? So you're getting these from the video. For this one right here, she will be stirring. She will be stirring for this one. The final temperature of the mixture is where it levels off. And she will tell you where it levels off. You can easily look at the data table, but she will tell you all of these. Like this one's at 18 minutes and 42 seconds. This one's at like 16 minutes. This one I think is at like 24 minutes, so you'll get all these. This one is very soft, so you may have to turn up your volume for that. Pretty basic. You're getting these off your video. All of these about 100, all of these lows 20s, all these mid 20s. I don't want to tell you the answers. The next thing, mass of water. Now it tells you to show all your reactions for the aluminum only. So make sure you do show work with units. If you want to include your work on a separate sheet of paper, you can do that. Well, they give you the density, so you know M equals D times V. Oh my goodness. Sorry, excuse me. You are not going to write number 8 on your lab, and you are not going to write number 3 on your lab. Okay? You're going to write your actual numbers for number 8 and what you got for number 3. And then you're going to say this equals a certain amount of grams. I would take it to at least 2 decimals. You'll get this in grams, and you'll repeat it for the iron, and then you'll repeat it for the lead. So you're taking your density from number 8, multiplying your volume in number 3, and you're ending up with grams. This delta T right here, again, you're not going to leave this on your paper. It's number 6 minus number 5. Show your work. You have to show your number 6 in degrees Celsius, your number 5 in degrees Celsius, and that's going to give you a degree Celsius. No units, no points. And all those are going to be degrees Celsius. This is probably going to be 1 decimal. This right here, this is your number 9 times your number 7 times your number 10. And again, make sure you show your units. So you're going to have grams times joules per gram degrees Celsius times degrees Celsius. And your units are all going to be joules here. You'll write your answer in joules. Then you'll repeat. You're doing all of this. You're showing all your work for aluminum here. Then you're repeating it for iron and lead. And this guy right here, your delta T equals number 6 minus number 4. Because you're doing the metal. Again, these are all going to be degrees Celsius. So have your degrees Celsius minus your degrees Celsius equals your degrees Celsius. You will have negative numbers for this value. You will have negative temps for number 12. Number 13 is applying your Q equals negative Q, which you should be familiar with. You're solving for C of metal, so I just went over here and I rearranged the equation myself, and it's mass of water times specific heat of water. They use C for specific heat, delta T of water divided by negative mass of metal times delta T of metal. Show all your work. So if I wanted to put numbers in here, this is going to be your number 9 in grams, and this is going to be your number 7 in joules per gram degrees Celsius, and this is going to be your number 10 in degrees Celsius, and this is going to be your number 2 in grams, and this is going to be your delta T, your number 12 in degrees Celsius. And if you look here, you can clearly see that your Celsius will cancel and your grams will cancel. And for all of these, you're going to be left with joules per gram degrees Celsius. And they should be very close to the specific heats if you wanted to look them up to compare to make sure you did your math correctly. You could easily look up the specific heat of aluminum and say, okay, my value's sort of close, so I must have did my math correctly. Because you take 9 times 7 times 10 divided by 2 divided by 12. A lot of you make that error, and don't forget about that negative. Okay, and then the molar heat capacity, that's pretty easy. That's just going to be your number 13. You just have to get your units joules per mole degree Celsius, your periodic table metal gram over 1 mole. So your units are going to be joules per gram degree Celsius times grams over mole, and your grams cancel, and your new units are going to be joules per degree Celsius mole. Make sure you put your units there. They're gonna crush you on units. So you have to do that for each one here. For aluminum, you use aluminum's mass. For iron, you use iron's mass. And for lead, you use lead's mass, and you get those masses from the periodic table. All right, moving on. Maybe. So this right here, write down all your observations. What happened? Did the temperature increase? Did the solution temperature increase? Did your substance dissolve? Did your substance not dissolve? Did the temperature flatten out? All of those are things that you need to show. So you took your solid and you dissolved it in water, and when you dissolve it in water, it broke up into its ions. And you need to show this. You need to show the charges of your ions, and you need to show your phases of your ions, or you will not get work for this. This you get from the video. And for the conclusion, just wait to see what you get in number 4. And for number 4, you're doing products minus reactants from table B at the back of your lab. If you get a negative answer for this, then it's exo. If you get a positive answer for this, then it's endo. Same thing for the ammonium chloride. Be specific on your observations. They want specific observations. You're taking ammonium chloride solid and you're dissolving it in water, and you get ammonium +1, aqueous, and then Cl -1, aqueous. Again, temperatures are from the video. Do your delta H, show all your work. If you just put an answer here, you're not going to get the work. You have to show what values you used. Show work. If you get negative, it's exo. If you get a positive, it's endo. And then for the thermite reaction, this is really easy on the video. Balance the chemical equation. You should be able to do that. Make sure you use phases and make sure you balance it. This guy right here, you should know the charges of these. What's the charge of iron 3 oxide? You know oxygen is always what? You know iron's has to be what? You know what are the charges of elements when they're by themselves? And then figure out the charge of aluminum and oxygen. If you wanted to do like a little example there, let's do this right here. Chloride would be -1. And chloride's -1, and there's 2 of them, so that's -2, so calcium has to be +2. That's an example of how you find these oxidation numbers. You're looking for the little pluses and minuses to the top right. 2 of these are going to be 0 because they're in their standard states. Magnesium ribbon, make sure you balance it and make sure you use phases. This is just a combustion reaction of magnesium. It's just magnesium reacting with oxygen. So Mg plus O2, and you can predict the products. This last part right here, it's right off the video. You're going to see that the metal is like shiny, solid, silvery. Make sure you tell if it's consistent with a property of a metal or not. Okay. Also right here, if you don't know this answer, Google it. Look it up. Try to find the answer. If you want a better thermite reaction, look it up on YouTube. There's plenty of better videos than what they showed you in this thermo reaction demo. Okay, it has to do with how the iron oxide has to be really close to the aluminum for the reaction to start. If it's far away, it's not going to have a reaction. And then part B is right here. This is your table B, where you get all your delta H values for all your products minus reactants for the whole lab. All right, I hope that makes it easier for you. The longest part is watching the video. You do have some down parts, like from the first video, 29 to 34 minutes, it's complete silence. So you can fast forward it through there. All right, good luck. If you have any questions, I'm here.